Hello and welcome to the second video lecture of Compiler Design and Construction. In this lecture I'm going to talk about Chapter 1, Part 1. Outline main topics, terms. We are going to talk about some terms such as data structures, compiler debugger, etc. Compiler related programs, the translation process and data structures. We are going to talk about a program related to compilers such as interpreters, assembler, linkers and loaders, preprocessors, editors, debuggers, profilers, project managers. And then you are going to talk about the translation process, which is basically the main job of the compiler to translate from high-level language to low-level language. So this translation is done in multiple phases. The first phase is the scanner, the second is the parser, the third is the semantic analyzer, the fourth is the source code optimizer, the next is the code generator, and the last is the target code optimizer. Data structures that you are going to talk about, which are tokens, syntax tree, the symbol table, the literal table, intermediate code, and temporary files. So we know that most of you are familiar with high-level languages such as C#, Java, C++, VB.NET, Frail, Lisp, Python, etc. And in contrary to this, we have low-level languages such as machine language and assembly language. So the difference is that high-level language is written in a language that is very close to human language, while low-level is the machine language, the binary language, or zeros and one. Assembly is a symbolic version of the machine language, so you could have a fixed format for this language, the instruction symbol, then the operands, and then the register, and so on. So this is the sample program written in C++. As you can tell, for those who are familiar with C++, this program displays the welcome string on the welcome message on the screen. So if you for instance remove the semicolon at the line cout welcome end line, if you remove the semicolon from this line, the compiler will tell you that there is an error in your code, and thus the compiler will not generate the machine code corresponding to your program, and then you cannot run your program. Because your program has a syntax error. So this is the output of this is the code written in the IDE code blocks. So IDE are semi-integrated development environment which facilitate the writing or the coding of a program. It has syntax, color highlighting. It has also a compiler built inside them. So while you are typing, the compiler will assist you by highlighting any syntax error in your code. So this is the output. The welcome is displayed on the output screen. So right now this is the same program, which is simply display the welcome message on the screen, but with an error. This error was made intentionally because we want to see what does the compiler do and what is the expected from the compiler. So this program that ends at the closing curly brace at line 7, this simply has a syntax error. According to the rules of the C++ language, every line or every statement in C++ language should end with a semicolon. There is no semicolon at the end of line 6, so the compiler will tell us that there is an error in your code, and thus it cannot generate the machine language corresponding to your high-level language, and it cannot run your program. So you cannot run your program because it has syntax error. So you can see the error messages is in function int main, error is expected semicolon before the closing curly brace at line 7. So you can see the compiler is what we expect from the compiler before it translates from our source code or high-level language to low-level language. It will highlight any kind of errors, syntax errors, semantic errors, and display error messages that helps us fix those errors. So this is the same program but with a different kind of modification. So right now we remove the statement include IO stream at the beginning of the code. So it tells us that cout was not declared because cout is simply an element that is declared in the library IO stream, and also int line is not declared, so the compiler could not recognize the cout command, which is used to display the message on the screen, and the inline command, which is used to make a new line on the output console. So the reason for this error is simply because we did not have an statement at the beginning of our code that is include IO stream, to include the library IO stream, which contains the definition for the cout command and the inline command, which is simply predefined in the C++ library. You don't need to define them. They are already defined, but you have to tell the compiler that I'm going to use the cout command and inline command in my code, and you have to include the library IO stream as in the previous code. So this is another example, odd even example. It's given an input number. It tells us whether the number is even and odd. It uses the modulus operator. If the number modulus 2 is equal to 0, that number is even. Otherwise, the number is odd. So this is the output. Enter a number. The user inputs using the keyboard 22. Then the program will display the number you entered is even. This is another example, factorial example. It calculates the factorial of a number. So the factorial in mathematics is the product of all numbers from the factor of n. The factor of the number n in mathematics is the product of all numbers from 1 to n. So the factorial of 3 is 1 multiplied by 2 multiplied by 3. Factorial of 4 is 1 multiplied by 2 multiplied by 3 multiplied by 4. Factorial of 5 is 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. So this is how we can find the factorial of any number, any input number using a for loop. So enter a number, the user input or entered the 3. Here the program calculates the factorial of 3, which is 6, which is basically the product of 1 multiplied by 2 multiplied by 3. This is the same example, factorial, but using recursion. So you could write the factorial program in two different ways, either using a loop, as in the previous example, or using a recursion, which is simply to understand the recursion, you have to understand what you mean by function, how to call function, how to execute function. So simply a function is a piece of code that has a name, return type, and optional and parameters. So you can execute the function by making a function call. You just simply type the name of the function, followed by the parameter that you want to pass to the function, and then the function will execute and then return the result to the function call, to the statement that called the function, or display some answers on the screen. So if recursion is when we have a statement inside the function that calls the same function but with the different parameters. So here is the implementation for factorial using recursion. So we have integer factorial function, integer num. So integer num is the parameter. If num is equal 1, the factor of 1 is 1, so return 1. Else return number multiplied by factorial function num minus 1. So factorial of n is equal to n multiplied by factorial of n minus 1. Factorial of n minus 1 equal to n minus 1 multiplied by factorial of n minus 2, and so on. So as we all know, the factorial of a number is the product of all numbers from 1 to n. Running your code, you have compiler, building, and execution or debugging. So in code block, this is, as I have mentioned, code block is one IDE. There are different kind of IDEs for different languages. For instance, Visual Studio is one of the most popular IDEs, integrated development environment. You can write code in C#, F#. You can also write code in C++, in Java, in C++, in Visual Studio. So to compile your code, you just simply go in using code block. You just go to the build menu and then click the compile current file. So this is since this code has no error, the compiler will say that 0 errors, as which is simply highlighted in the blue color in the window logs and others. So 0 error, 0 warning, and then the time that it took the compiler to compile your code. So that means the object code or the machine code corresponding to your code corresponding to your C++ code is ready right now to execute. So building is simply compiling your code also. So to build your code, just go to the build menu and then click build. So this is the same output. To run your code, you go to the build menu, click run. So you can see right now we have the message from the compiler in the window logs and other build log, and then also we have the output of the code, which is welcome in the console, black console window, as we see in this slide. So right now we have seen some example code, and we have seen some how to execute, build, compile our C++ code. So right now we'll discuss the theoretical concepts behind compiler. So what's a compiler? A compiler is a translator from high-level language to machine language. So this is a black box view. We have the program is passed to the compiler. The compiler will generate the machine language corresponding to your program, machine language version of your program. Why compilers history? So we have different kind of programs: machine language, assembly language, and high-level language. So for instance, this is an instruction in machine language C706000002, which is simply, I think, as far as I remember, C7 is the instruction for adding, as far as I remember, adding the content of register 2 to the content of register 0. The assembly language is a symbolic version of the machine language. So we have move x2. I think C7 is move, not add. You can check it in the textbook. And so move x, 2 will move the content of register 2 to the memory location x. Another instruction, add R1, R2, R3 will add the content of register 3 to register 2 and store the result in register 1. So machine language is an instruction in binary language or hexadecimal language. Assembly language is a symbolic version of the machine language. So it's well structured. Every instruction begins with the command, followed by the operands or register numbers and memory locations. High-level language is more flexible, more readable, more portable than assembly and machine language. So for high-level language are written using grammars. So we are going to talk about the grammars in chapter 3, context-free grammar and parsing, finite automata and regular expression. So regular expression is a mechanism for specifying the pattern of tokens. We'll see what you mean by tokens in chapter 2. More details in chapter 2 in the scanner when we talk about the scanner. Finite automata is an algorithm or a visualization of the steps of regular expression, which allows us to visualize all the steps in recognizing or rejecting a string that belongs to the language. Programs related to compiler. We have interpreters, assemblers, linkers, loader, preprocessors, editors, debugger, profilers, project managers. So interpreters and compiler. Interpreters are execute the code immediately. Example is Lisp and BASIC, used in education. Compiler preferred if speed is desired. Assembler translate to assembly language, which is a symbolic form of machine language. So if you are using an assembler and a compiler, then your compiler will translate. Your assembler will translate your code into an assembly language. Then you are going to convert the assembly language code to machine language. Linker link code in different files together, so it's possible for your project to have multiple files. Linkers will link your code together and links your code to any predefined library that you are using in your code. Example of use: link object programs to libraries and resources in memory. It isn't given too much attention since it depends on the operating system. Loader convert the relative memory references to the start of the program to actual physical memory addresses so that they can be used in the executed code. Make the executable code more flexible. So we know that when you write your program, it's going to be converted into machine code. So in machine code, you have to have a fixed memory location. So if you are referring to memory location X in your code, it's going to be translated into memory location corresponding to your program, to the position where your program is going to be loaded. So for instance, if you're declaring a variable at the beginning of your code and then you are loading your program into memory, then the loader will convert your X memory location to memory location that simply corresponds to actual physical memory address in the memory. Preprocessors separate the program code by compiler before actual translation. Does the following: delete comments, include other files, macro substitution. Editors, it's where you write your program. So I have mentioned IDEs and code block for C++ language, which is an editor for C++ language, and I have also mentioned Visual Studio, which is an editor for C# and F# language. So it's where you write your program, combined with compiler into integrated development environment, IDE, structure-based editors. Debuggers used to find errors while executing the program. So the compiler will find the errors in your code, static errors. We call that, it finds the static errors. There are other kind of errors which are runtime errors, such as division by zero, file not found, and so some other kind of error. So if your code divided by zero, divide two variables where the second variable or the denominator stores the value 0. Then if your code is going to divide by 0, and in this case the compiler cannot detect that kind of error, it's going to be just simply your code is going to cause or produce a runtime error. And using the debugger, you can find those kind of runtime errors. So the debugger will help you find exactly which line of your code caused the runtime error. And also, if you are referring to a file, if you are trying to read a file from your code, and then the file does not exist because you gave a wrong file name or wrong file path, then the compiler will not find that kind of error because it's a runtime error. The compiler is only concerned about writing instructions or writing your code such that it conforms to the rules for writing the language. So for instance, any identifier name start with a letter, for instance, as we will see in upcoming topics. Identifier name, which is the name for variables, for function, for classes, for object, start with a letter followed by letter or digit or underscore. So for instance, this is one kind of rule. If you start an identifier with a number, then the compiler will tell us that there is an error, and then you cannot run your code. So the compiler can detect those kind of errors because simply any error that's concerned about the writing of the language, the syntax of the command, the compiler can detect. But runtime errors such as division by zero, wrong file path name was given, you are attempting to read from a file that does not exist, for instance, those kind of errors are marked as runtime error and the compiler cannot detect them. If you want to fix those kind of errors, you can use a debugger. If your IDE comes with a debugger, debugger used to find errors while executing the program, integrated with the compiler into IDE, difference between debugging and running. Breakpoints, you can also use breakpoints which are flagged lines where you want to stop the execution when the compiler reaches it. So this is all done in the phase of developing your program. So I'm not talking about deploying your program to the end user and then running your code. I'm still talking about modifying your program, trying to fix the errors and all of these things that takes place while you are still writing, modifying, developing your program. So don't confuse running your program with the final stage. So we're not talking about deploying or running your code on the user machine yet. So a debugger also allows you to flag some lines as breakpoint, and then if you debug your code, it's going to run the code until that breakpoint. So this allows us to exactly identify which line of code caused the error, what is the value of the variables, and different kind of analysis that allows me to fix the code and correct those kind of runtime errors. Profilers used to improve the performance of a program, collects statistics on the behavior of an object program. Project manager used to manage the work by different programs on the same program. Example of use: coordinate the merging of separate versions of the file, maintain a history of changes of the file. Translation process. So we have different phases for the translation process. The first phase is the scanner, the next is the parser, the next is the semantic analyzer, the next is the source code optimizer, then we have the code generator, then the target code optimizer. So chapter 2 talks in more details about scanner, chapter 3 talks in more details about parser and context-free grammar, and also chapter 2, which is the scanner, talks about regular expression and fine and automata. Chapter 3 talks about the parser and context-free grammar. Then we have the rest of the chapters as explained or listed in the syllabus. So this figure is very important, shows the overall stages for the compiler. We have on the left side the stages of the compiler or the phase of the compiler. We have on the right side, we have the data structure that are used with the compiler. So we have the stages or phases of the compiler start with the source code. So the source code or the code the programmer write is simply the main input to the compiler. So this source code or the code written in C++, C Sharp, F Sharp, Java, whatever is the high-level language, is the input to the compiler. And we know that the compiler consists of different stages. So the source code is passed to the compiler. In particular, it's passed to the first phase of the compiler, which is the scanner. The scanner reads the code or the source code character by character, and then identify and find out the tokens in your code. So we know that in English language, the basic unit of the language is the words. We have characters, but also the smallest meaningful unit is the words. In high-level language or C# or C++ language, the basic unit is tokens. So for instance, we have the bracket, left bracket, square bracket is a token, right? A bracket, closing bracket is a token. For instance, we have 100 is a token, that is a token of type number. For instance, price, which is a price for a bill or something like that, is another token. Its type is identifier token. So the scanner objective or the scanner goal is to find the tokens from, extract and find the tokens from your code. Then it will pass those tokens to the parser. The parser, using the context-free grammar for the language, in this case the C++ language, it will construct a parser tree. So this parser tree has two different types of elements: leaf nodes and internal nodes. Leaf nodes corresponds to token in your code. Internal nodes correspond to the structure that these tokens represent. If the parser was able to construct the parser tree or the syntax tree using the tokens, that means the instruction is correct or the statement in your code is correct and it follows the rules and syntax for the language. Then the parser, after it generates the syntax tree or parser tree, this will be passed to the semantic analyzer, which will annotate the syntax tree with the data type to make sure that there's no type mismatch. For instance, you are not assigning a character to a number, a variable of type number, and so on. Then this annotated tree is passed to the source code optimizer, which will produce the intermediate code. The intermediate code maybe will be in some other intermediate language, expressed in some intermediate language, will be passed to the code generator, which will produce the target code. Then the target code is passed to the target code optimizer, which will produce the final target code or the machine language code corresponding to your source code, which was passed to the compiler. So that structure used with the compiler, we have the literal table, which stores the literals in your code or constants. For instance, 199.3. For instance, the string will come to the class, and so on. We have the symbol table, which stores information about the symbols in your code. The error handler also is used as a data structure. So the scanner, the first phase of the compiler, right now we're going to talk about in more details the phase of the compiler, different phases of the compiler. The first phase is the scanner, which takes as an input the source code and produces as an output the tokens. So it performs lexical analysis. It's about the characters that constitute different tokens, reads character by character and forms tokens, enters identifiers into simple table, literals into literal table. For example, giving the following instruction: a left bracket index, closing square bracket, equal to 4 plus 2. So for those of you who you have to know some kind of basics of a programming language to just simply pass through this course. So this instruction assigns the result of 4 plus 2, which is 6, to the array element that is at position equal to index. To the array element a index, which is simply a refers to the name of the array, index is subscript or the location or position for the element in the array. So array is a sequence of elements that simply are adjacent to each other. All of these elements can be accessed with the single variable name or the array name, which is a in this case. So to access the first element in the array, use a between brackets 0. To access the second element, a between brackets 1, and so on. So depending on the value of the index, if the index is what's equal to 4, then this is going to store 6 at the position 5. Why? Because indices or subscript of the array start from 0. So the first element in the array is a between brackets 0. And the second element has the position number 1. The third element has the position number 3, 2, and so on. Sorry, number 2. So array indices start from 0. So the first element is stored at position or index 0. The second at position 1. The third at position 2, and so on. So if you pass this line of code, a index equal to 4 plus 2 to the scanner will find out the tokens in this line. So for instance, a capital is an identifier, it's a variable name. Left bracket is a left bracket. Index is an identifier. Then we have the square bracket symbol and its token, which is right bracket. Then we have the equal, which is an assignment. Then we have 4, which is number, plus, which is a plus sign, and 2 is a number. So so we know that left bracket, the symbol for left bracket is a left bracket. but you have to, this is simply basically the token for left bracket is not the same as the symbol for the left bracket itself. The token for left bracket is simply represent an internal representation for this kind of tokens, which is could be written as left bracket or could be written in a different kind of token name. So you have to distinguish between the token name or token type and the token value. For instance, for the first token in this line of code, its value is its string or symbol. We will see. You can check the textbook for more details. Its symbol or string is A, but its type is identifier. So each token contains some information about each token that it represents. So the token type, the token value, the token string. So for numbers, for instance, the 4 is read as character, but it's actually stored as a number. So that if you are adding to this number, you are going to get 6, the number 6, as in this example. So we will see more details about tokens and the scanner in chapter 2. The second phase of the compiler, which is the parser. The parser takes the output of the first phase, which is the scanner, which is simply the tokens. So the scanner reads the source code character by character, perform lexical analysis, and produce the tokens. The tokens right now are passed to the parser as an input. The parser, using the grammar of the language, will construct a parser tree. If the parser was able to construct the parser tree, the instruction is correct, is syntactically correct, has no syntax error. So perform syntax analysis, structure-based analysis, similar to a natural language processing or grammar analysis. So we are right now, it's widespread. One of the widespread application in computer science is natural language processing application that understand any text written in natural language. For instance, search engines such as Google and Yahoo uses some kind of a query that could be expressed or written in a human language. So you could write a query in an English language, and then the search engine will respond to your query. So this is one branch of natural language processing language, one major application for natural language processing. So for natural language processing, to write a program that understands the text, it does what we call parsing. So parsing is simply verifying or analyzing the structure of your text. So if you are, since we are talking about natural language processing right now, the parser for English language will identify the different structure in your English statement. Will identify the noun, the determinant, the verb phrase, and the noun phrase, and everything will be simply is mapped to a structure in English language. If the entire structure of the of your English language line correspond to a structure in an English language, then the parser will returns that your statement written in English language is correct, syntactically correct. So the parser for programming language is the same. It identifies the structure of your instruction based on the rules written for the language. So for instance, in C++, an assignment statement has the following structure: identifier name, the equal operator, and then expression on the right side. So in any assignment statement that has this following structure will simply simply considered true as it's structurally correct. So the parser uses the English language or the context-free grammar to express the rules or the different structure for different value structure for English language. The syntax tree, so the output of the parser is the syntax tree or parser tree. So internal nodes are named by the structure they represent. Leaf nodes are tokens of the program. Abstract syntax tree are reduced from the syntax tree. So this is the parser tree for the previous instruction, which is a index equal to 4 plus 2. So you can see right now there are different ways to construct the parser tree, either from top to bottom or bottom to top. There are two different chapters about this. So you can see the leaf nodes at the end of this tree, at the last level of this tree, at the bottom of the tree are tokens. So we have a index for 2. Sorry, a left bracket index right bracket 4 equal 4 plus 2. So the leaf nodes are the nodes that has no children. Internal nodes that has a children. So you can see the a identifier with the left bracket, with the index, with the right bracket, all constitute a subscript expression or an array reference expression. And subscript expression is one of the valid type of expression in the C++ language. Then we have the 4 plus 2 together are an additive expression. An additive expression is one of the valid expression in C++ language. So expression equal expression is one valid type of the assignment expression, and assignment expression is an expression. So the entire statement or the entire line of code is an expression in C++. So it is true, has no kind of syntactical errors, has no kind of syntactical or structure errors. Semantic analyzer determines behavior at runtime. Static semantics, the data types checking, therefore can be analyzed by the parser. Data types are attributes and are added to the syntax tree. The semantic analyzer validates the types of the expression and returns a time mismatch if there is no error. The source code optimizer, constant folding, 2 plus 4 can be replaced by 6, performed in the syntax tree. 3 address codes such as t equal 4 plus 2, a index equal to t. This will be just simply be optimized to a index equal 6. This is called the 3 address code. The code generator, intermediate code, any internal representation for the source code used by the compiler. It converts intermediate code to machine language. So here's an example of assembly language. Move R0, index, multiply R02, move R1, address A, add R10, R1, R1, R0, move R1, 6. The target code optimizer improves the code generated by the code generator. Examples: replacing slow instructions, choosing addresses, modes, eliminating redundant or unnecessary operation. Major data instructions in the compiler. We have talked about tokens, the syntax tree, the simple table, the literal table, and the intermediate code and the temporary files. So tokens are strings with identified meaning or the smallest element in each program command. The compiler may need to store the string literal or the number value associated with each token. For variable tokens, the compiler may need to store the characters of a string variable, the value of a numeric value. Syntax tree. So what's a tree? So a tree is a cyclic graph. Is a graph with no cycle that contains nodes and links or edges between those nodes. So if there's a node, special node that simply starts the tree, which is called the root of the tree, and then it has children. If each node contains 1, 0, or 2 children, then we call that a binary tree. So internal node. So we are going to use the syntax tree is one kind of a tree. So it's simply where the internal nodes are structure representation, and the leaf nodes are the tokens. So what's a syntax tree? It's a tree that contains the tokens of the program along with information about each token. Each token is represented by a node in the tree. Example: for an integer variable x that's defined as integer x equal 10, we will need to store the following: the node, the identifier name x, the data type integer int, and the value 10. The information in the nodes are simply the output of the parser, tokens, and later by the semantic analyzer data type. What is a syntax tree? It's a tree representation of the syntax of the program based on the type of units that each of tokens encode. Each node is recorded, is a record whose fields represent the information collected by the parser and semantic analyzer. For example, the expression grade equal mid plus 10 will be represented as in the following short form of the syntax tree. So in this syntax tree, it represents the structure of the instruction grade equal mid plus 1. So we see the root is each assignment, because this is simply an assignment statement. The left child of the assignment is grade, right child is a plus, is an expression that contains an additive operator. Then the plus operator has 2 operands or 2 children, the variable mid and the constant or literal 10. So this is also a parse tree. We talked about this before, so you can see the leaf nodes to represent tokens. So we have the identifier A, the left bracket identifier index, right bracket equal operator, for number 4 plus operator, and then number 2, and then the parser will construct or identify the structure in your statement. So a left bracket index right bracket is a subscript expression, which is an expression. 4 plus 2, which is an additive expression, which is an expression, and expression equal expression is an assignment expression and is an expression also. So this for a left bracket index right bracket equal 4 plus 5 is a valid syntactical instruction in C++ language. So right now the parser will pass this parser tree to the next phase, which is the semantic analyzer, which will annotate the tree by data types to verify that there are no type mismatch in the assignment statement. Example of the assignment tree, for instance, you could build an example of syntax tree. You could build a syntax tree for the if-else statement, the while statement, and so on. So the example just simply has one kind of a statement, which is the assignment statement. Example for a syntactical program, verifying the grammar in an English statement, check Stanford parser online. The simple table stores information associated with identifiers, functions, variables, constants, and data types. Interacts with every phase of the compiler. The information in the nodes are simply the output of the parser tokens and later by the semantic analyzer. Code generator use information stored in the symbol table later. For a compiler, we need the memory address. For an interpreter, we need the value. So this is an example of a simple table. We have three different variables. The first variable is income. Its data type is integer. The address is 1000. Value is 100. The second variable is student name. Its data type is string. Address is 9C20. Value is Bungie. The third variable is z. Data type is double. Its address is 1010. Its value is 2.9. Literal table, it's used to store literals and constants. Example for string literals, we have Harindra, Erika, Ahmad, please input a number. So all of these are string literals or string constant. Example of character literals, we have A enclosed by single quote, C enclosed by single quote. So character variables or literals store characters. A string literals store strings. Example for double literals, we have 100.00009 3.14, which is the pi constant in mathematics. Intermediate code kept as either array of text string or temporary text file, which are simply kept as an array of text string. So a temporary text file was used because simply they had limitation memory in the past. So they could not save everything, so they save some kind of information or numbers or some kind of data into a temporary files so that they can be loaded later and then used to continue the computation. Linked list of structure and so on. In the past, due to memory limitation, compiler used memory files to store the result of intermediate phase of the compiler. Back batch not required. So this is the end of the part 1 of chapter 1. So tomorrow, on Thursday, I'm going to post the exercise to Blackboard. It's going to be done in groups. And then next week, I'm going to continue with the second part of the chapter. Also, on Wednesday, I'm going to take the attendance at 3 o'clock by conducting a Zoom meeting. So please make sure you do your best to attend the meeting so that I can take attendance and follow up with you regarding any kind of concern. Thank you very much and see you on Wednesday.